So differentiating again, we're going to have d squared y over dx squared, which is equals to, if you differentiate this, if you differentiate minus a sine x minus a sine x, if you differentiate this, remember how we do it. Differential of the constant, which is minus a, is going to give us 0 multiplied by sine x, is still the same thing as 0, plus the differential of sine x is cos x. Differential of sine x with cos x multiplied by minus a is going to give us minus a cos x. So we come over here, minus a cos x plus if you differentiate b cos x, if you differentiate b, which is a constant, it's going to have, you're going to have 0 multiplied by cos x, still give you 0, plus differential of cos x is minus sine x multiplied by b, going to have minus sine x multiplied by b, going to have minus b sine x. So you come over here and put minus b sine x. This will be equal to d squared y over dx squared, which is equals to minus a cos x. You know, this plus will multiply with minus to give us minus b sine x. And if you look closely, in the equation 1, we have y equals to a cos x plus b sine x. And here we have d squared y over dx squared, which is equals to a minus a cos x minus b sine x. We are looking for a way to equate this to make y equals to this. To make it, we have to factor out minus. So we can still say d squared y over dx squared is equals to minus bracket a cos x plus b sine x. You know that this thing is still the same thing as this, because this minus will multiply what's here. We have minus a cos x, which is here. This minus will multiply this plus. We are going to have minus. That will have minus b sine x. This thing here is the same thing as here. Is the same thing as the equation here. But if you look closely, y is equals to a cos x plus b sine x. Therefore, you can easily equate. We say this is equals to y. Therefore, we have the squared y over dx squared is equals to minus y. Bringing y to the other side, no, y is negative here. When it comes to the other side, it's going to be positive. Therefore, I have the squared y over dx squared plus y is equals to 0. Therefore, this is the final equation. This is the ordinary differential equation that's corresponding to this equation. Now to example number 2. Moving over to example number 2, y is equals to a e to the power of bx. To solve this, we have to differentiate twice because the equation involves two constants, which is a and this b, which is used as the power. Therefore, we say if you differentiate once, the y over dx will give us equals to, you know, the coefficient of x will multiply everything. Therefore, we have a b arranging in alphabetical order, a b e raised to the power bx. If you differentiate once, you're going to have this. Call it equation 1. Then we can still, to make our work easier, we can factor out a so that y will be, so that we substitute for y for, we can factor out b2 so that we substitute for y for ae raised to the power bx. dy over dx is still the same thing as b bracket a e raised to the power bx. What I did here is very simple. I just factor out b, so to have b bracket a e raised to the power bx, so that I will substitute for y for a e raised to the power bx in equation 2. Therefore, if we substitute, we're going to have dy over dx, which is equals to by, because in equation 1, y is equals to ae. In the first equation, y is equals to ae raised to the power bx. Substituting for y, you're going to have dy over dx equals to by. Call it equation 3. You know, this equation contains two constants. Therefore, we have to differentiate twice. Differentiating again, we're going to have d squared y over ds squared is equals to, remember what I told you in the beginning, to differentiate this y owns the constant. Therefore, this constant now is no more a constant, it's now a coefficient of y. Differentiating this is going to have b dy over dx. If you differentiate y with respect to x, you're going to have dy over dx. Call this equation 4. But if we look at this equation 3, we have that dy over dx is equals to by is equals to by. Therefore, we can make b the subject of the formula. Once we make b the subject of the formula in this equation 3, we substitute what we have for b in equation 4. Then we can solve to get the ordinary differential equation that is corresponding to this equation. So let's do it down. In equation 3, we have dy over dx, which is equals to by. This is what we have in equation 3, right? Therefore, you make b the subject. If you make b the subject, b is equals to dy over dx. Normally you say to make b the subject, you're going to divide by both sides by y, so that this y will cancel this y. And dy over dx, this thing is equals to dy over dx divided by, you can say divided by y. But let's change this division sign to multiplication sign. So if you change it to multiplication sign, it's going to be 1 over y, inverse of what is dividing. Therefore, b is equals to dy over dx multiplied by 1 over y. This is now a b. Then we substitute for b in equation 4. Anywhere we see b, we substitute it with this. Therefore, we have in equation 4, we have the squared y over ds squared, which is equals to b dy over dx. This is what we have in equation 4. Substituting for b, going to have the squared y over ds squared is equals to, b is equals to dy over dx multiplied by 1 over y. Therefore, dy over dx multiplied by 1 over y multiplied by the dy over dx. Then, since dy over dx are the same thing, these three things are multiplying each other. We can still say that the squared y over ds squared is equals to, this multiplying itself is going to have dy over dx all squared multiplied by 1 over y. From here, we can still solve we need to clear this fraction, because there is nothing like fraction in an equation. So to clear this fraction, we multiply both sides by y. So the squared y over ds squared multiplied by y is equals to dy over dx all squared times 1 over y multiplied by y. This y will cancel this y. Therefore, we have this multiply this, we have y the squared y over ds squared is equals to dy over dx all squared. Now we equate everything to 0 to get our ordinary differential equation that is corresponding to this equation. Equating everything to 0, we're going to have y the squared y over ds squared is minus, because this is positive. Once you move crosses over to the other side, it's going to be negative, minus dy over dx all squared is equal to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation. Thank you.